Hello, hello. Trying to find my video. Hello. Hello. People whose comments I can't yet see. Curious I had had such a good stretch of finding the video quickly. And now we have gone awry. And I didn't fix the date at the top of this. It is the 10th. Ninja edit. There we go. Good job. There we go. Finally found myself. You have 5 meetings today. That's a lot of meetings. I have 1 or 2. Should check to see if I have a second one. Uh, hmm. Unclear. Yeah, quite unclear. Maybe not. Maybe I only have 1 meeting today. That's okay. Welcome, welcome. I got 3 questions for you here. Of the more free response variety of question here. While these are shorter questions, and well, actually 2 and 3 kind of go together. So, yeah, it is actually kind of a free response question to start us off here. And hello, Daikun, Michael, Sam, Matthew, and Maddie. Hello, Chelsea. Welcome to the people just showing up. I'm glad I started the stream on time because I was playing games up until about a minute before the stream started. So. Related rates helps on SATs. Yeah, reading word problems is one of the premium skills on the SAT. So, uh, just practicing related rates makes you better at the SAT, just from the reading standpoint. Hello, Bryn. Welcome. I got these 3 questions here. Can you believe it's the 10th of April already? Holy smokes. It's my buddy from high school who had drug overdose several times. Birthday today. I think that's April 10th. My buddy from grade school who got into drugs in high school when I didn't. Haha. Who owns a tattoo parlor now. And who I haven't talked to in like 7 years. Feels bad. Drugs are bad. I keep messing up and not actually bringing music to this. Next week is spring break. I know you guys are so excited because you haven't felt like you've been on break much lately, but yay, spring break. And it's going to be nice weather and stuff, so that's kind of cool. Oh, Michael's done already? Hello, Michael. Oh, it makes sense. You were the first person here besides Tycoon. You were the first person who commented besides Tycoon. And hello, Tim. Kennedy, when are you going to stream in the coming weeks? The principal sent out a schedule for the week we come back from spring break. And I'm hoping that schedule will not be what the case is after this. Because that schedule is not live stream friendly, which is a frustration for this class specifically. For Algebra 1, it's not that big of a deal because I was already doing 2 videos and 1 live stream, but for this class I was doing triple live stream. I don't like... Well, let's be as careful as possible. The current schedule sent out... Oh gosh, was that sent to parents already? So it's unrenegable or whatever. The current schedule is not live stream friendly for those of us that want to live stream all of our classes and blah blah blah. So I don't want to commit to it before. Yeah. I'm nervous. It is Monday and Thursday. I would probably oh God. The frustration for those of us that like to live stream is that you will have stuff going on in your other classes, and I would only want to live stream once because, like, even when I live stream for all 3 of my classes, I get about a class worth of kids showing up and asking questions, whereas if I live stream for each individual class, I would get way less people. I'd get something like 10 to 15 maybe for each section. And I'd have to do the same thing 3 different times, which seems like a complete waste of time. And a lot of those people, or if I just did it once and did it for the first one, and then made the other people watch videos, then they couldn't ask questions live, and it feels like it's just way less good. I don't know. I'm a little frustrated. It is not conducive to the way I've set things up, and I'm bummed about that. It's a schedule that makes sense on paper, but not if you think about it, which feels bad. So that's my ranting about the schedule. So I'm praying that something will be edited with the schedule so that it makes it more conducive to actually holding live class, because that's what I like to do. So yeah, a little bit frustrated. And I see those dones piling in. I'll probably go over this in about a minute. So I'll hang on for a little longer. Maybe ramble about some other stuff. I don't know, man. But as far as next week goes, we're going to have a live stream on Wednesday that's like this one. Just a bunch of math practice. And that's the plan for the spring break week. That live stream, like I guess any of these, up until starting next week, things are a lot less optional. Next week, rather, when we come back from spring break. So it's the last week of like semi-optional into less optional. All right, we're up to like half as many dones as there are people in chat. So if you separated variables in that first one, hopefully you got this. Hopefully you integrated both sides and got natural log of the absolute value of y equals x squared plus 3x plus c. And then just e both sides. And you get c e to the x squared plus 3x equals y. Beautiful. Just one of our classic differential equation type questions. With, I think, the actual hardest part being factoring out the y in the first step to separate variables effectively. I think that's actually the hardest part of that question, because the rest of it is very much like most of the questions we've done for that. Second question. We have this beautiful rate here, R of t, of people entering this building. There are 20 people in the building at the initial time. How many people are in the building after 3 hours? Well, we're just going to take the amount of people that start in the building and add the integral from 0 to 3 of the rate people enter the building. And so if you integrate, you get 3t squared minus t cubed over 3. You plug 3 and 0 into that, but only 3 has a value, and you get 20 plus 27 minus 9. So how many people are in the building? 38 people after 3 hours. Why does it become 3x instead of negative 3x? Because I can't read the negative sign, and so this should have been a negative in both spots. Thank you, thank you, thank you. Yes. Good job, y'all. Thank you for pointing out my mistake. Oopsie daisy. Alright. The third one says if the rate of people leaving the building is 5 people per hour, after how many hours is the building empty? So the way we need to start this one is like kind of figure out how many people are in the building after 6 hours, because people are only entering the building from 0 to 6 hours. And so we'd have to do the integral, so basically 20 plus evaluated at 0 and 6 of 3t squared minus t cubed over 3. So the total number of people that enter the building and start in the building is 20 plus 3 times 36. Yeah, separating variables is integrating, Daikun. So those are the same thing. So dope. Minus 6 cubed over 3. Okay, so 6 cubed is 216. Or really it's like 6 times 6 times 2, because it's 6 times 6 times 6 divided by 3, which is 2. And 6 times 6 is 36 times 2 is 72. So this is 20 plus 108 minus 72. So after 6 hours, if nobody left the building, there would be 56 people in the building. But because 5 people are leaving the building per hour, then actually after 6 hours, we're down to 26 people in the building. So, I mean, this is now a linear equation. We have 26 people left in the building. They leave at 5 an hour, so it's 5.2 hours after close. So 6 plus 5.2 hours is a total of 11.2 hours after the opening of the building or whatever, when it's finally empty again. So I kind of modeled this question after the free response I did on the last video because it had the kind of feel of this one. And I was hoping people were able to get this one because they had seen a question like this before. Are people cool with my answers to this? 128 minus 72 is not 28. Oh, yeah. It's 36. But yeah, 36 plus 20 is 56. So whatever I said was wrong, but the number was correct. So that's pretty cool. So yeah, the math is not crap. So that's pretty cool. So I'm a little confused, Daikun, with your fragmented messages, but I don't see any other complaints. Mostly just about my negative 3x, which was indeed super crummy. All right. No updated questions or anything. I mean, realistically, all you need to do this is figure out that 56 people total came into the building. And so if they're leaving at 5 an hour from this just static rate, then 56 divided by 5 is 11.2 hours, and that would get you there. Do you think we won't go back to school until 2021 when we have a vaccine? Possibly. Yes. I was talking. So I have friends who work in medtech research, and I called a couple of them just to kind of get their feel because I'm a nerd and I like to know things. And they're working on COVID stuff right now. Those because everybody in the medtech field is working on that right now. And the general consensus is that we're gonna this wave is gonna go through and it's probably gonna wrap up in a month or two, and then it's probably gonna come back kind of seasonally, maybe October, November of next year. And so maybe we go back to school in September because it's kind of worked its way out. But if another wave comes through, we'd be going back to something like this, unless there's a vaccine before then, which we'll see. Widespread vaccine stuff is a little questionable. So, yeah. Sorry about that if that's bad news for you. Okay. Part 2. Yeah, imagine never going to school. Here is part 2. Asking you a couple interesting types of questions here. A couple different type of questions. If you haven't showed up to a Friday stream, we basically do like 3 different kinds of warm-ups, and then I just answer whatever questions people have, and then we wrap it up. So Fridays are a little less me talking just specifically about how to do math, and more me rambling. Oh, hey, Elmer. What's up, dude? Trying to figure out if that picture is you, because it has no hair. So, without the flat top, I don't know if it's Elmer. Definitely not me. Okay, good. Good. Hopefully you haven't lost the flat top because, man, if there's one hairstyle I wish I could have, still, it's that. But is number one garbage? No, number one is not garbage. Number one is a very specific type of question. I think I can roll it. I don't think my hair is like curly enough or whatever. Ugh. I should get a perm. Oh yikes. Ugh. I don't think my wife would let me do that. She doesn't like when I grow my hair out. So sad panda. How do I start number one? When you're trying to take the derivative of a piecewise function, your derivative is also going to be a piecewise function. That's my hint. So, like, it's going to have all the same boundaries. So, you should be able to kind of get it set up from that. Like, the x is less than 0, x is between 0 and 5, x is greater than 5, that whole thing. Yeah, I'm not quite the Napoleon Dynamite guy. I don't think I have his swag. Like, he's definitely a better dancer than I am. Yeah, there are a lot of sophomores in chat. You guys are right. Lots of bromance. Speaking of bromance, I'm watching Community again. I think I shouted it out last stream. And if you haven't seen Community, it's on Netflix. It's amazing. You should watch it. And there is a very adorable bromance in that show. You are the only freshman here, Elmer. Yes. You watched all 6 seasons this week? Nice. Sorry you watched the Gas Leak season. Watching with my wife here, we're probably going to skip season 4. Maybe watch a couple episodes from season 4, but I'm fully with it being called the Gas Leak season. I watched it all live because, you know, I'm a boomer. And yeah, it was a little sad when they got rid of Dan Harmon. Why would you get rid of the creator of Rick and Morty off your TV show? You clearly don't know what you're doing. All right, let's start talking about these questions. So this was my hint I gave. And then we just take the derivative of these three things. 2x, 2, 5 over x. Those are the derivatives of each of the things. And then you just put the bounds on. So this looks like it's going to be scary and isn't scary. It just isn't. Like, it's 3 different derivatives, none of which are even hard. And you just put the same bounds on. What did Elmer do? Not a lot. So what he's telling you to do is stuff. Like, actually do things. If you separate variables in the second one... Wait, why am I separating variables? That's really dumb. See, that's the bait mistake. If you're trying to find the tangent line, all you're going to do is use this equation to find the slope, which is 2, if you plug in 2. And then you just do y minus y1 equals slope times x minus x1. Wow, that's actually a really easy equation. And then you plug in 4, and you get what y is. So 2 times 2 equals y minus 2, so y is 6. Chillin'. Is 5 natural log of x equal to natural log of x to the 5th? Yes. And just a little sidetrack, since I already finished here. If we took the derivative of this, it'd be 5x to the 4th over x to the 5th. And if you cancel out the x to the 4th, here it's 5 over x, so you get the same thing. So, proof it's the same. So that's kind of cool. All right. Last question of the day is an AP question. I tried to pick a relatively family-friendly one, so let's try this one out. This is a no calculator question, even though it has an E and stuff. Here's what I'd like you trying out. It's got some of the change direction, speed, acceleration, distance. Give it a try. Huh. It's nice when chat goes quiet and I know people are working. Feels good. Do I play Minecraft? I do not play Minecraft. I'm like too old for Minecraft. I just like missed it in almost every single way because I played a lot of video games and a lot of types of video games, and Minecraft's probably a type of video game I would have played, maybe? I don't know. I played Terraria for like 5 hours, and Space Terraria, whatever that was called, Starbound, for like 5 hours, and both games I just couldn't get into, so I don't know. Maybe I just never got into that type of game or whatever. Microsoft Flight Simulator 2020. Feels like a game I'd rather watch than even play, to be honest. Like, it just looks pretty. Yeah, I have looked it up. It looks pretty amazing. Like, I found my dad's old assisted living place because it's next to the Boeing airport, and you can land at the Boeing airport, and that's like way too real. Like, ugh. Like you can crash into your own house. It's that realistic. It'd be really funny to play the Kahoot music in the background while we're streaming. I wonder if they would get mad at me for that. I don't monetize my videos, probably not. Like do virtual Kahoots here. uh, Yikes. Okay. Liam, really? Liam, come on, man. Some of us lived through that. Maybe not right now for that. Daikun, why would you spoil everything? Slash, hopefully you did things right. Alright, probably gonna go for a couple more minutes. So, Liam, I think unlike Grand Theft Auto, which is another game where you can do stuff kind of like that, when you crash in Flight Simulator, I think the flight simulation just ends. Like, it's like you lose. Like, I played a lot of the old uh, Flight Simulator, and that was my experience. Was that there was no graphicness when things finished. Like, nothing was graphic, so uh, it wasn't too bad. Uh, like destructible buildings is something that you really want in your Call of Duty game, but probably not in your flight simulator game. Yeah, exactly. uh, um, Whoa, Dylon's here. That is a name I haven't seen for a minute. Let us begin. Find the acceleration of the particle at t equals 3. Well, you take a derivative, and it's a really hard derivative. That's the derivative. And you plug in 3, so you get negative e to the negative 2. Is the speed of the particle increasing at t equals 3? Well, we have the velocity here. Speed is the absolute value of velocity, but if we're looking for where the speed's increasing, really we're looking for where the velocity and the acceleration share the same sign. So we have to find our acceleration equation by taking another derivative, and if we take another derivative, we just get e to the 1 minus t. And it's pretty obvious, I don't even need to plug in the number. If I have e to the 1 minus t and negative e to the 1 minus t, they aren't going to have the same sign. So it is decreasing. So it is not increasing because they have a different sign. Different sign. The two different signs are e to the negative 2 and negative e to the negative 2. This being the velocity, this being the acceleration. It is increasing. Ha, get wrecked. Huh? No? They're not increasing because they have different signs. E to the negative 2 is 1 over e squared. Negative e to the negative 2 is negative 1 over e squared. And those have different signs. So the velocity is negative, but the acceleration is positive, so the speed is decreasing. No, the velocity is negative e to the 1 minus t. So velocity is negative e to the 1 minus t. Acceleration is e to the 1 minus t. We just keep chaining out a negative 1 every time we take a derivative, so it'll switch back and forth between negative and positive. Is that a good reason? Because I did not do what you did. Yeah, the reason I gave is a really good one. Let's see. You said at t equals 3, the acceleration value is negative, so the slope of the velocity of graph. That is definitely not good enough because the acceleration is actually positive. E to the negative 2 is 1 over e squared, which is positive. So the velocity is negative, but the acceleration is positive. Oh, the velocity equation is that one? Oh, psych. Oh gosh, oh gosh. Blame Mr. Kennedy for all of the first world problems that I am dealing with. Okay, let's fix this. Oh, sad panda. I derped really hard. No wonder so many people were correcting me. I blame Liam. Okay. Yeah, now that's fixed. Now let's check those signs. It might be increasing now. Logic was right, but was the work right? No. Okay, negative 1 plus e to the negative 2. That is indeed negative. And our acceleration is also negative. And that means they're both negative, so we're actually increasing our speed because they match the same sign. So thank you. Liam accepts the blame. Nice. All right. I was able to dodge it this time. All right, we're fixed. Logic-wise, the big idea is just checking velocity and acceleration, seeing if they have the same sign. I checked the wrong equations. It turns out the acceleration's rate, speed, the absolute value of the acceleration is decreasing. That's what I proved with my work. The average jerk, or I don't know, man. Find all the values of t at which the particle changes direction. Well, now that we know this is the velocity equation, we just set it equal to 0. So 0 equal to negative 1 plus e to the 1 minus t. We add 1 to both sides. We natural log both sides. The natural log of 1 is 0, which makes this math really easy. Oh, super chillin'. T equals 1. So that's a possible point where this changes direction. So we should test values on either side to ensure that it actually changed direction, ensure that the velocity changes sign on either side. And if we plug in 0 and 2, we get negative 1 plus e to the 1. That's positive. And if we plug in 2, we get negative 1 plus e to the negative 1. And that is negative, because negative 1 plus 1 over e is still a negative number. 1 over e is less than 1. So it actually changes sign here. And so this is full justification, finding the point, making sure it actually changes there. And so t equals 1 is the spot where it changes direction. And our last one says find the total distance traveled by the particle from 0 to 3. So I'm going to wipe out some of my sad panda section of this. All right. We just integrate from 0 to 3 for distance traveled, but because it's distance traveled and not like find the total distance you end up from your starting position, displacement, we actually have to absolute value our velocity. To integrate it, like meow. Because, yeah, absolute value is required for this sort of thing. Now, the nice part about finding the absolute value of this is It's a relatively kind equation to absolute value, because we can fairly easily figure out where it goes through 0 and then split this to two integrals. Because -1 plus e to the 1 minus t looks something like, how to graph this thing. So logically, we could tell from putting in points that we start off with positive values close to 0. So we start off like something like this. And then we switch to negative values when we pass 1. That's when we change direction. So 1 is the point at which I need to like reflect this part up to actually solve the integral correctly. So I can't actually integrate an absolute value as is. I have to split this to two integrals. One for the part that is positive, that happens first, and one for the part that is negative that I reflect up, which happens second. So because 1 is where it changes direction, I'm going to have to integrate from 0 to 1 of the original function, because that's where it's positive, -1 plus e to the 1 minus t, and add the integral from 1 to 3 of the inversed function, the multiplied by -1 version. They flipped over the x-axis version, which looks like so. And you just solve these two equations. So this integrates to -t minus e to the 1 minus t. The beautiful thing about the integral of e to the 1 minus t is it's the same as the derivative of e to the 1 minus t. So easy money. This one here, we integrate and we get t plus, wait, why did I put, oh yeah, it is minus, t minus, or plus e to the 1 minus t. All right, cool, because I chain out that -1 and it becomes positive in there. Now we just plug in all the bounds and stuff. That's a -t in that one. Okay, so -1 minus e to the 0 is plugged in, and 0 plugged in gives me 0 minus e. And so the area of our first region is e minus 2, which is indeed positive, so it's an absolute value. We can tell from the positiveness of it that we didn't mess up too much there. Second part of the question, we plug in 3 and we get 3 plus e to the -2 and minus 1 plus e to the 0, so 1. So this is e minus 2 minus 3 minus 2 is just 1, plus 1 over e squared, which is e to the -2. And we just kind of add these two terms together, or like honestly, that's our final answer if we want the total distance traveled. So that last part was like very hard comparatively. Daikun, your like 2-word helps are almost never helpful, and I did do the absolute value in the very first part. I don't know if you missed that, but I integrated and split to two different integrals because that's how you deal with absolute value. You can't integrate an absolute value, so what you do is you split to two equations where you've reflected up the negative parts so that they're above the x-axis. And yeah, part D of this was like way harder. Parts A through C, all pretty easy unless you derp like me and don't realize it's a velocity equation. But D was heavy comparatively, and quite a bit more work. Any questions? This makes more sense. Wow. Okay, cool. That's good. Splitting it up makes sense now. Yeah, actually, we have no way of actually dealing with absolute value without splitting up. So, I was actually meaning to do one of these types of questions and then didn't realize I had put it in the free response I had given. Is Lake Wilderness Park open? Looking to bike there after this. There are signs, I know, at the trailheads, so my guess is it's not open. I know Seattle's closing almost every major park, and a lot of municipalities are closing parks. So I would, yeah, it's pretty tenuous whether or not things are open right now. They're trying to crack down pretty hard, which brings us actually to the last slide here. Recommendations for spring break slide. Observe social distancing. The virus has done worse here, which means it hasn't actually been that bad here compared to some other places in the country, because we've actually followed the guidelines here. And slash we have a lot of people who could work from home pretty early on, and that helped a ton. So the Microsoft people, the Google people, the Amazon people. So please, please, please don't start hanging out with big packs of your homies in close proximity, just because this is a thing. And the weather is going to be nice, so like go outside, but just keep a distance from your homies if you decide to hang out with them. I'm seeing packs of kids in the neighborhood where I live, and I'm concerned that is not good for the virus thing. Maybe we'll see an uptick because spring break stuff. All right. Anyways, there's a review stream Wednesday, 1 p.m. next week, same as normal. Then after that, things are going to get pretty hugely different because the principal made a schedule that is sketchy. Am I going to do Zoom at all? Probably not. I like YouTube. I like the control and stuff. Probably not going to do Zoom. Yeah. Masks don't help a ton. What is the schedule? I'm hoping it's not the schedule, so I don't want to tell you yet. I'm going to tell people for sure with an email that I'm going to send over spring break. So, are you going to split classes or do one straight? Yeah. I know. It's really weird what's coming. My hope is that sanity reigns and we get departments getting our sections instead of class periods getting our sections. I'm hoping that happens still, but if it doesn't happen, then I'm probably going to stream once. And like not every teacher is going to stream, so if you can make it, great. If you can't make it, you can watch it later. 180 minutes a week is almost full school days. That is not true. Just do what you've been doing. Yeah, it's probably going to be something like what I've been doing. I'm going to have one stream. It'll probably be earlier in the day because I have to do it earlier in the day or some crap. I don't know, man. Well, I'll figure out like some time block. We'll try to get as many people there as you can. You can watch it late if you want to. You can always pause and like fast forward to when I go over it if you watch it later, and maybe that's even more convenient. But yeah, that's the way I'm dealing with that. We'll see how things work out come next week and the week after. I'll probably have an update for you on Wednesday. I do need to send out an email to like parents and crap today, because I'm supposed to send one of those out once a week, and I haven't sent one this week, so, yeah, that'll happen soon. And anyways, have a nice day. We actually ended early, so it makes up for the other ones going long and over an hour. Lunch is 180 minutes. uh, yeah. Yeah. See you Wednesday next week. All right. Later.